This video will be about all of the numbers. Before you is a table that organizes every possible number that can possibly be conceived or imagined in every form that it can have by just asking 5 questions about the number. The first question being, is it real? Well, if it's real, yes, it's real. If it's not, it's complex and imaginary. So for the purposes of what I'm going to show for the rest of this graph, I'm going to focus only on the real side, because you can almost, for everything, transfer everything that's on the left side to the right side, no problem. So from real, we would ask, is it well ordered? Now, if it is not well ordered, it is what we would call unknowably infinite. And if it is unknowably infinite, we cannot ask the next 2 questions about it, which are, is it definitive and is it determinate? Because for things that are unknowably infinite, both of those questions are automatically going to be no. The charge of something unknowably infinite can be positive, negative, 0, or non-existent, meaning that it can have any of the other 3 types of charges. If it's positive infinity. If it's negative infinity. For 0, it is what I call 0 the infinite. And for no charge whatsoever, it is what I would call omega everything. What do I mean whenever I say something is definitive for the third question? I mean, can we write out everything about that number? For example, if something is definitive, you can write it down and have it expressed in its numerical format. So if something is definitive, it is finite. And if it's not definitive, but it is well ordered, it is transfinite, what George Cantor would call a transfinite. So I'll just use that word too. Now, if something is partially definitive, it means that we can write out a lot of the numbers, but not necessarily all of them, and it is what we would call irrational. For everything that is irrational, we can write out, like for pi, 3.14159, but we do not know the final digit of pi. So it is also partially determinate, because if it was determinate, we would be able to write down the final digit of pi. And for irrational numbers, when they have a 0 charge, that is an infinitesimal. I'll get more on that in a second. Whenever we say something is determinate, if it is real, well-ordered, definitive, and not determinate, we get either negative everything, positive everything, or if there is no charge to that, it's just everything. If it's transfinite, let's go up here. If it is not definitive, but it is determinate, it is a specific transfinite ordinal. Negative aleph null, positive aleph 1, all those different transfinite ordinals that George Cantor expressed in his writings. There's all these different zeros on here that I should explain further. Let me get my pencil. Not pencil, it is a marker. It would be bad if I drew on this with a pencil. All right, so let's say for all intents and purposes that there are only 3 finite numbers, and there are only 3 transfinite numbers, sorry. All right, so this is the end line for the finite, and that's the end line for the transfinite. Now, if we were going in the positive direction, this would be switched. The finite would be over here, the transfinite would be over here. But we'll say that, say for infinity, there would be 0, 0, 0, all for the finites, and then 0, 0, 0 for all the transfinite, and then it would just keep on going until there is a 1 so far out that we do not know where it actually begins, where infinity starts. So going in the opposite direction, how I originally intended to go, for expressing all of these different zeros down here, there is 0.000. So 0 the finite has zeros from as far as we can possibly know. We cannot know anything really beyond what is this. We cannot definitively know the zeros that go beyond here. But just as a way of organizing the different kinds of numbers, we say that 0, the finite, could have a 1 right here, but we just want to know it because it's it would go beyond of what we are capable of knowing. So a 0 finite stops here, 0 that's transfinite goes zeros all the way to this line, and there could be other numbers over here that we just don't know because it's not well ordered. And 0 the infinite has zeros all the way. Now an infinitesimal would, since it has a 0 charge and it's irrational, has a 1 that is, we'll say that it is because it is well ordered, there has to be a 1 somewhere in the transfinite category. And I think just for all intents and purposes, it would be best to define the infinitesimal as having the 1 right there as the infinitesimal. Because beyond that, we can't even write these zeros. These zeros shouldn't even be here because be blah, 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 blah. It could be total nonsense, and we wouldn't even know it. Do I have anything else that I need to say about this? Let me think about it. Oh, imaginary. All right. Get this. So if you have zeros, so we need to take another look at the imaginary complex side of this, because whenever you ask all the questions about it and you finally get down to the charge of being 0, this 0 down here should be 0i. But whenever you multiply anything, if you multiply I by 0, you get 0. So in this expression, it just simplifies down to being 0 the finite. So it's almost like it's not even imaginary anymore. It just comes back over here. And the same thing goes for the imaginary 0 the transfinite. It also just comes over here. Actually, there might be an instance where multiplying 0 by a transfinite would be different because it's also a kind of infinity. So it might end up being something else. I'll have to think about that more. Well, that is all the numbers. Multiplying, say, Aleph Googleplex by 0. Yeah. What if it's omega, omega, omega? It's still well ordered, but the 0 that you're multiplying on it, we only know up to the 0 the finite. So that's why it's better just to keep 0 as 0. Because whenever you try to overcomplicate it, the thing is we don't know anything beyond the finite, so it's like we're playing with games we don't know. So for all intents and purposes, based off what we describe, it's like multiplying an unknown by an unknown again. Multiplying by 0 would definitely make it less than the original set that you multiplied it by. So you could bring, just me quickly thinking, like if you multiplied this expression by 0, the final answer would definitely be less than this original expression. But it's also infinite, so it may actually be able to escape 0. So I'm just trying to think from what point 0, like what is this range that this expression can go to? Well, you got to hear me think in real time. Until next time, goodbye, Mother Duckers. If you have any questions or think that any of these concepts weren't explained very well, or you want to ask questions to actually understand it better because you think I might be onto something, let me know in the comments below. See you next time.